You had a little bit of an introduction to Lewis dot structures with the covalent bonding gizmo. So we're going to discuss the last night's video, rules for drawing Lewis dot structures. Now, I've looked many different places, and I've seen many different rules on drawing Lewis dot structures, and I'm not real sure if I like any one set of rules. I don't know if you can really have just a single set of rules for drawing these dot notations. And it's a little bit, how you want to say it, a little bit outside the bun, outside the box. But when we are drawing these Lewis dot structures, we're dealing with the electron dot notation of the elements. So the first thing we need to do is we need to gather our available information, which means that you need to know the dot notations for each of the compounds that you're dealing with. So it's going to be a little bit different of a dot notation than the way that we've drawn them out. And I'll tell you exactly what I mean by that. Okay? It says here, when placing valence electrons around the atom, place one electron on each side before pairing any electrons. Now, where that is going to be different, folks, is the big one is carbon. If you and I were drawing the electron dot notation for carbon, we would draw it like this. Correct? We would fill in our dots 1, 2, 3, 4. Now, when we're drawing these dot notations, if we're drawing carbon, we're going to fill in the dots, okay? We're going to place one electron on each side before pairing. So I would draw carbon as so. So when I'm drawing this Lewis dot structure, it's going to be slightly different than how I drew my electron dot notation. And it's all about bonding sites, places that this carbon could potentially share electrons with other elements. Second thing we need to do is we need to determine the total number of valence electrons that we have in our compound. Second part is to arrange the atoms. We need to arrange the Lewis structures to show how the atoms bond. A couple of rules. Halogens and hydrogen often bond with only one other atom and are usually at the end of the molecule. What I mean by the end is the outer portion, not the center. If you stop and think about the halogens and hydrogen, how many valence electrons do they have? How many valence electrons do the halogens have? 7. How many does hydrogen only has? 1, but it only needs 2. So hydrogen and the halogens only need one more to complete their outer shell, right? So does that make sense that they're only going to bond with one other thing? If you have carbon, it is placed in the center of the molecule. with the exception of carbon, the center of the molecule is usually the atom with the lowest electronegativities. So if you don't have carbon, look at the electronegativities. The one with the lowest electronegativity you're going to place in the middle. Distribute the dots. Okay, distribute the dots. Your goal that you're trying to achieve is the octet rule. What was the octet rule? What was the octet rule? With how many? With 8 electrons. The octet rule is filling the valence level with 8 electrons. Now, it says up there, exceptions to the rules: hydrogen, beryllium, boron. Those are exceptions to the rules because they do not satisfy a full octet. And we'll learn about that here throughout the school year. Change each pair of dots into dashes. We talked about dots to dashes when we talked about single, double, and triple covalent bonds. So, change your dots to dashes and then verify the number of valence electrons with each atom. And determine that you have not gained or lost any electrons unless you were supposed to. Unless you were supposed to. Now, you saw this diagram on the video notes. I hope you have this diagram in your notes. If you do not have this diagram in your notes, take the time right now. I'm going to give you a couple of seconds here. Take the time right now to write this diagram in your notes if you do not have it. What this diagram is showing us is it's showing us how most of the nonmetals want to bond, or the possibilities. And you can hopefully see the similarities. Now, if I look up here, we talked about hydrogen and the halogens wanting to bond with one other thing because they have one open bonding site. Okay, so up top there are all of the halogens that want to single bond. Now, the second row is the oxygen family. So, if you remember with oxygen, when we draw the dot structure, we would draw it like that so that I would have 2 possible covalent bonding sites in oxygen, right? So, does it make sense here that oxygen could make 2 single bonds, or it could double bond? Okay, it could make 2 single bonds, or it could double bond. Well, look on your periodic table. Okay, if you don't have it out, look on mine up here. Does it make sense that oxygen, sulfur, and selenium all act the same way? Yes, because they all have the same number of valence electrons. They're all in the same family. So if you have oxygen, sulfur, selenium, it's either going to have 2 double bonds or 2 single bonds or 1 double bond. Now look at nitrogen on the periodic table. Nitrogen and phosphorus. If I would draw up nitrogen here, I would have my N, and I would put my dots around so that with the nitrogen, I could have 3 possible bonding sites. Therefore, I could have 3 single bonds as here. I could have a double bond and a single bond. 1, 2, 3 open sites, or I could just have a triple bond. 1, 2, 3. So nitrogen could bond in 3 potential ways. Phosphorus is right below nitrogen, so phosphorus, it makes sense, would have the same bonding patterns. Now carbon, I already drew carbon up on the board for you and said that we put 1 on each side, so it has 4 possible bonding sites, and you're going to see that anything that equals 4, okay? 2 and 2, 1, 1, 1, 1. 1, 1, 1, yeah, that was 4 of them. 1, 1, and then a double equals 4. A triple, and then a single equals 4. Okay? So this is going to be very helpful for you to determine the the Lewis dot structure. It's going to be helpful, this diagram here. Now, let's just start out real easy. Okay? Let's start out real easy. I look at this and I see a couple of things to start with. Number 1, I have carbon, don't I? If I have carbon, I want to put carbon in the middle. So I'm going to start off by drawing the electron dot structure for carbon, and I'm going to put it in the middle. Now, with carbon, I go back and think and say, okay, I just had that diagram where carbon was looking like this, with those 4 things, correct? Now, in this instance, I have to decide how I'm going to bond carbon. And I look. If I'm using this carbon right here, I would probably have something here and something here. So I would have 2 other things. This carbon, I would have 4 other things. This one, I would have 3. This one, I would have 2. So I look here and say, okay, I've got 4 other things, and those 4 other things have 1 open bonding site, don't they? So what I'm going to do is I'm saying it is going to be this one right here, because I have 4 things with 1 open bonding site, and with carbon I know I have 4 open bonding sites. So all I'm going to do is I am going to bond 4 hydrogens onto that central carbon. So if I draw this structure using dashes, not dots, I'm going to draw it as so. Now, what I like to do, folks, when I'm drawing these, I like to do it like this, and I have different colors out. So when you're making these, I think it's helpful to see them, to see whose dots belong where if you use the different colors. So it helps me picture it a little bit better. Okay, so we've got 1. We've got 1 in the books. Here's another one, NF3. Once again, the things that come into my mind are nitrogen wants to bond like that. Nitrogen could bond like that. Or nitrogen could bond like that. Those are straight off of my diagram, right? Which one of those 3 do you think makes the most sense, knowing that you have 3 fluorines? Absolutely. The first one, because I've got a spot 1, 2, 3 things there. If it were this one, there'd be 1, 2, and this one would only be 1. So really the only one I can bond on here is the first one. So I'm going to draw my nitrogen. I'm going to have its electron dot structure. I know fluorine is a halogen, so it has 7 valence electrons. So I'm going to put a fluorine there. We'll put a fluorine here. And we'll put a fluorine down here. Because I know each fluorine has 7 of its own electrons. So basically, in this Lewis dot structure, I have 3 single covalent bonds. If I were going to draw it out using just my dashes, I would have F, N, F, F, as so. They get a little bit more challenging, folks. Okay? They get a little bit more challenging, but not quite yet. Here I've got oxygen and fluorine. I need to decide where I'm going to start building, so I need to know what to put in the middle. I don't have carbon, do I? And I guess I should have discussed this with the last one. I just threw nitrogen in the middle because I knew it. I don't have carbon, so I want to put the least electronegative one in the middle, which is which one? Oxygen. Fluorine has the greatest electronegativity of all. So I'm going to put oxygen in the middle. I know that oxygen has 6 valence electrons. So I draw in my 6 valence electrons. I know that oxygen was as so or like that, correct? Now, which one of these do you think it's going to be? Okay, I guess that other O doesn't need to be there, does it? Is it going to double bond or have 2 singles? 2 singles, because we know fluorine only wants to do what? Single, right? Fluorine's a halogen, it only wants to single. So I'm going to put a fluorine here, because that's where I have a bonding site open. And I'm going to put a fluorine here. Now, one of the biggest questions I get on this, is, I drew it like this. Somebody will say, well, Mr. Braun, what would happen if I drew it like this? It's a different way than I drew it, right? However, that's the same. All right? That's the same. The way these things take their shapes, you're going to learn next week when we talk about something called VSEPR, valence shell electron pair repulsions, and we'll talk about molecular geometry. But that's next week, okay? So, you can draw those either way. I could even put them both on the top and on the bottom, and that would be okay. Now, my next one is a little bit different here because I have a lot more gunk, a lot more stuff. I have 2 carbons, I have 1 hydrogen. Now, one thing that we're going to learn about carbon is that carbon likes to make chains of carbon. Carbon likes to make chains of carbon. So if I have multiple carbons, I'm going to bond them together. So I'm going to have 1 carbon here, as so, and I'm going to bond to that my 2nd carbon. Now, as I put those two together, can you see that I have 3 open bonding sites to each carbon? Can you see that? Can you see that I have 6 hydrogens? 3 and 3 is 6. 6 hydrogens that like the single bond, right? So, I'm just going to take and I'm going to put a hydrogen at each one of those open bonding sites. And I have 6 hydrogens, don't I? Now I go back and look. Are my carbons obeying the octet rule? Do my carbons obey the octet rule? Yes. Do my hydrogens obey the octet rule? No, but do they have to? No, they don't. They only need 2, right? So we've just now drawn the Lewis dot structure for C2H6. Now, what happens? What happens if you don't have enough electrons? We need to make double and triple bonds. Now, obviously, we just did C2H6, right? And we had 2 carbons and 6 hydrogens, and they were all single bonded, right? Well, now we only have 4 hydrogens. So something different's going to happen. I'm going to start off the same way, and I'm going to put my 2 carbons together. Now I have 4 hydrogens, right? I have 4 hydrogens. In order to make my bonding make sense, I'm going to 2 and 2 them. I'm going to put 2 of them here on this carbon, and I'm going to put 2 of them here on this carbon. So I've got all of the valence electrons that I can have already there, don't I? I can't create any more. We can't just poof, come up with valence electrons. So I've got to figure out a way that these obey the octet rule with what I have here. Well, I can see that I have an open one here and an open one here, right? What I need to do is just shift those open ones and make a double bond. So what I'm going to do is I'm going to move those 2 electrons that were there into the middle. So now I'm sharing 4 electrons. When I share 4 electrons, it is a double bond. So if I look, does this red carbon have 8 electrons? It has the 4 that's shared, these 2. So if I look right here and I draw my circle around that carbon, does it have 8 electrons? Yes. What about the other carbon? Yes. Okay. So now, if I'm drawing this out, I put something like that. Because I have the H is single bonded, the carbon is double bonded. Here's yet another one. Now I've got two less carbons to work with. So, once again, where I started, I know carbons like to make chains, so I'm going to chain together my two carbons. Whoa, 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 Bron, what are you doing? I'm going to chain together my two carbons, and I have two hydrogens. Where would you put the two hydrogens? What do you think? On the outsides? Yeah, I mean, they got to. Would you put one on the red, one on the blue, or two on the blue, or two on the red? Huh? Yeah, put one on each. So I'm going to put one on the red one on the blue one. Now I've got everything that I can have, I've got already. So I've got to make this work. What am I going to do? I'm going to bring these two in, these two in. Can carbon triple bond? Can carbon triple bond based on your diagrams? Yeah, sure it can. So what's going to happen is we're going to bring those in as so, and when I look, let's look at blue carbon. Does blue carbon satisfy the octet rule? Yeah. Does red carbon satisfy the octet rule? Yeah. So what I've done here is I've made a triple bond between two carbons, and then I have bonded onto it also a hydrogen. Okay? Now, what I want you to do I want you to try these two, okay? We're going to work these two. I'll work them up here after the break, but I want you to try these two to see how you would do them, okay? Okay. I have the first one, carbon and two oxygens. I'm going to put carbon in the middle. But what I'm thinking right now is I'm thinking oxygen is this. The two ways oxygen can bond, right? So I look at that and say, okay, would it make any sense for me to single bond both oxygens to one carbon? Doesn't make any sense because I'm going to be a little bit short. But I know that both of these have the possibility to double bond. So what I'm going to do is I'm going to double bond oxygen there, and I'm going to double bond oxygen here. Now, could I have single bonded and got these to work out? No, we would be missing. We wouldn't be obeying the octet rule. But as I look at each one of these, if I draw my circles, oxygen has 6 valence electrons of its own, the 6 green ones, and it shares the 2 carbons. So is that oxygen obeying the octet rule? I look at the carbon, 2 double bonds, 8 total, right? Is that carbon okay with the octet rule? Then I look at the blue oxygen. Is the blue oxygen okay with the octet rule? Yes. Now, what would happen, I'm just going to show you, because oxygen can only bond one other way, single bonds or double bonds. If I would have single bonded this, here I got that. Let me put an oxygen here. Let me put an oxygen here. Now I look, is anybody happy there? When I make my circles, how many do I count there? 7, right? That's not happy. How many there? 2, 4, 6. That's not happy. 7 there. That's not happy. So, if I would just single bond that, I'd say, no, this isn't going to work. This isn't going to work. Nobody's going to be happy there. Now, on our final one here, okay, once again, I'm going to build off of my carbon. Okay. I look at that, I say, okay, I have oxygen. So let me put an oxygen here, just single bond it. Now, I have 2 hydrogens left, right? And here's the part of you just got to know where to put them. Okay? You just got to know where to put them. And what I'm going to do is I can see that my oxygen's not happy, is it? I could put a hydrogen right here, but the only way that I'm going to get this to work out is if I make a double bond. So what I'm going to do is I'm going to double bond this carbon and oxygen. Now, is my oxygen happy? Does it obey the octet? Yeah? What about my carbon? Not yet, but I still have what? I still have 2 hydrogens, don't I? Well, could I put a hydrogen here and a hydrogen here? Could I do that? Yeah. And don't you know, isn't it on your carbon with a double and 2 singles? Isn't that on your list for carbon? Yeah. Okay, so that's where that list comes in handy. Okay? That list comes in handy because I look at that list and I see carbon like that, I see carbon like this, I see carbon like this, and I am missing one. Oh, 2 doubles. And I see carbon like this. So when I have to pick one of those out, I look here and I say, okay, here would be with 2 other things. Here would be with 4 other things. Here would be the one with 3. And I've got 3 other things right there with the carbon. That helps me pick out to see, okay, what way do I want to bond it? What makes the most sense? Okay? Now, believe me,